Welcome to the Energy InSites podcast, your source for the latest insights in deep retrofits, renewable energy, and energy conservation. And now let's get to today's insights. Okay, welcome back, everybody. So this is Energy InSites first. Leave it to Dean and Ben to continue their path of innovation. We are going live outside the Green Building Technology Access Center for a quick tour of the facility.
Yeah. Awesome.
Ben and Dean, thank you for rejoining us. Tell us a little bit about what we're looking at.
Okay, take it away, Dean.
Awesome. Well, I wish I had my sunglasses on because it's nice and sunny outside. We're standing outside SAIT's Green Building Technology Access Center, which is part of the Applied Research and Innovation Services department here at SAIT. It's a fantastic living lab facility, focusing on all aspects of green building, high performance construction. So let's go for a tour. You can see our facility here. Essentially built on passive house principles. We have a large-scale solar PV system. In our parking lot here, we have a large-scale solar carport. We have a nice zero-scape, low-maintenance, water-conserving landscape on the front. And we have a nice, brand-new sprung structure, insulated tension membrane that houses other infrastructure. And yeah, this is it's a pretty unique building. So look forward to showing you inside.
And this is on SAIT campus. So you also have students that are coming and getting training in your facility. What kind of certification are your students walking away with?
So we mainly work with so there's that Xeriscape garden that Dean had mentioned there. We mainly work with the continuing education programs here at SAIT. Sometimes work with industry with Passive House Canada as well, where we do, like, we have some air tightness training with Passive House Canada coming up just in mid-September here, where they're going to come and use and hold that within our tent. You'll see kind of the training space we have in there. We've done new construction and retrofit labs for how to do detailing in that.
And I would add, so we engage with students on all aspects, whether it be within their capstones, within their current programs, potentially within their practicum weeks, co-op placement sometimes. And I just wanted to showcase, this is one simple example of allowing students from the integrated water management and the environmental technologies program, they've embedded sensors in the ground that they're actually doing and applying within their program. They're checking on clean moisture content. That's just one simple example. Engaged in all aspects of student involvement across many of the programs within SAIT that you wouldn't even think apply to green buildings. So with software development students to look at upgrading energy management software for the information and data that we're capturing, integrated with film studies, broadcasting. We've engaged with them. They've come and helped us record information sessions. So outside of the typical architectural technologies or construction management or some of the trades, whether it be electrical or plumbing, we try to integrate with as many programs on SAIT campus as possible.
Yeah, majority of the diploma programs at SAIT, maybe head inside, Dean. Majority of the diploma or degree programs at SAIT kind of wrap up with a capstone project. And with those students working on their capstones, sometimes we can align those with an ongoing research project that we have. Other times we can look at just supporting them with their capstone idea. But there's a wide variety of things that we do. This building here also is a living lab. We do research in the building, on the building itself. One case in point is this floor coating. This was a project we did a few years ago with Zilla Bioworks. So they have developed and patented a hemp oil-based resin for like epoxies and such. So this was a collaborative project a few years ago with the University of Alberta, with a research group there, where they looked at taking that resin and developing a floor coating out of it. And we helped them with some mechanical, physical property testing of that, to verify how the properties compared to floor coatings on the market. And then we kind of wrapped up with installing this coating on our floor to see how it's going to work. It's been a few years now, and it's looking just great. And this is a common walking path. Everyone that comes in our building essentially comes through here. So it's holding on well. The idea is once they're ready to do some refinement on it, we can look at scraping that one off, putting the second version on, and seeing. So that's just one project example of some of the work that we've done.
It's just an office space technically here. We used to have water features that were built into the building itself. However, once the team grew, we needed some extra desk space. So the actual concrete cistern that we have is underneath these desks here. And I point that out once we're in the basement. But this is also a nice office space, a nice working space. Kitchen area, the lab itself is meant to kind of, in theory, replicate, residential scale type structure or pool. Once we follow down here, yeah, good.
Yeah, and while you were walking by it, all that pine on the wall there is all pine beetle kill salvage material, yeah?
Yeah, that's correct. So the fungus and impacts of the pine beetles make the wood non-structural, but it still makes good aesthetics for the building as well. So
maybe you could explain it quick conditioning bay here.
Yep. So we have this conditioning bay here. A lot of the tests that we do, kind of third-party ASTM standards, require materials to be at kind of a baseline of being conditioned at a certain temperature and humidity for 24 to 48 hours or sometimes longer. So when we have active testing projects on the go, we'll have this on and maintaining temperature and humidity and condition the samples before we run it to testing. Because a lot of properties, if the sample has a much higher moisture content or is at a much higher or lower temperature, when we begin a test, it could impact the results that we get from it.
And I would highlight the fact that we kind of focus on building materials, but then we have the ability to pivot and to kind of switch gears. You'll see some samples of another project that's focusing on reusing asphalt as paving stones. So, from actual buildings to walkways, we can do it all.
Yeah. Yeah, and that's a project too. It's a fun one, looking at two sources of asphalt, both road asphalt and from asphalt shingles, and how can those, and there's a manufacturer that's developing and refining their manufacturing process right now to produce a higher volume. But how can we take pavers from those sources, and use them in place of traditional concrete pavers, and how would that perform? With that thermal testing we did for that, it's really to help inform the manufacturing process of what's the thermal conductance and how long does it take to heat it up to melt it down and get it formed.
So I'll quickly highlight, this is our water lab area. And involved here is our large scale 35,000 plus liter concrete cistern. So we're harvesting all the water, the rainwater and snow melt off the building itself. And we're using that within the building to flush toilets, for some outdoor hose bib applications, and potential living wall, to try to use non-potable water, rainwater for that matter, city water. So, the building itself, referenced earlier, the kind of testing bays that you want to highlight.
Yeah, and we have, here's the thermal storage battery, or the phase change material battery. So this is a SunAmp Thermino battery. So we did some research with this in the past, and we're queuing up some research now to be going forward, to be involved in some pilots and monitoring and use cases, working with Eden Energy and Summerhill Group and some others as well, to look at how these thermal storage batteries can be used not only to support homeowners and building occupants, but also how can they impact and or reduce impacts and peak loads on the grid.
Yeah, phase change is really interesting and exciting. I'm
Yeah.
very, very keen to see how that can play out in Canada.
Yep.
This is an example of a small scale combined heat and power unit. We've done these are the 3 different bays. We've moved a couple of the other CHP systems up to a different location, but these are give us flexibility to test multiple different applications, multiple different type of energy sources. Testing infrastructure.
Yep. And then last over here, we mentioned earlier, this is our heat flow meter. This is where we can take and put a material in, roughly a 12-inch square sample up to about 3.5 inches thick. We can pop it in there and test for the thermal resistance and thermal conductivity of the material. So that's kind of our basement lab area, the main features that we have on the go right now down here. So maybe we can head up to the other lab space, Steve.
We should also mention that our building is outfitted with hundreds of sensors, both within testing bays like that, but also monitoring water flow. We have sensors embedded within the envelope itself to wall sensors and what have you. So we've got a number of different projects on the go, and including a number of, like I said, student projects that we're now actually trying to make use of to dig a bit deeper into our own data.
Yep. And we're
Amazing.
also to that point, I'd say we're also very collaborative in the research we do, trying to see what other research groups are out there and other entities and how we can support moving things forward in the industry. So to that end, if there's anyone watching or listening to this that is curious to see some of the data and has an idea how they can use it, just reach out and we can have a conversation.
Yeah, and it really shows our earlier conversation about gray water. That pocket of the basement there where you had all kinds of valves and gadgets and filters and pumps, and it's not as cut and dry as hey, just put a bucket under the sink and put it in the toilet or whatever, right? There was actually a lot of complexity there, some of which you did out the gate, some of which you had to add later to kind of satisfy the city and whatnot. And it certainly goes to show you how tricky that whole thing is.
Absolutely, yes. So water management is it can get complicated pretty quickly. When we think of, you could jump from a rain barrel that's just located on your downspout out in your garden or next to your house outside, to now actually harvesting and reusing internally. That is an unbelievable jump.
Yeah.
And complexity and equipment and maintenance. So
for sure. All right, so now we're into the shop.
We'll head up to our sprung structure. This is where we house, we have a large-scale 10-ton crane that we apply and use when we need to move larger objects around our facility. Come in handy when needed. Maybe I'll let Ben speak to some of these components in here.
Yeah. Well, I guess the speaking can be kind of minimal, the purpose of the walkthrough, because we just talked about it earlier. But here's the main structural rack that we mentioned before. We have a sample wall in there. So this has all been recommissioned, and we just redid the hydraulics, the loading and control and measurement system on it just earlier this year as well. So we're all up and ready to roll on this to do some fun testing. We've worked with a wide variety of partners in the past and helping support testing of their systems.
This was a unique recent project in the sense that we created our own customized controls and data acquisition system. So it was with another principal investigator here within the applied research, and then multiple students actually. One came out of our software development program, and another that was a Belgian exchange student. So this is great application of customized, internal. We've done it ourselves, but then integrated students within development type things.
And so you can test different wall assemblies in there, and you're essentially squishing them and torquing them and putting different pressure points on them to see how much deflection, how much tension, how many pounds per square inch or what have you can put on it before you deform or destruct.
Yeah, one of our main things, going back to previous conversations about like supporting clients, really work with them to find out what they need for their service, like what data do they really need. So with this apparatus, we can apply a load with a ram up to tens and thousands of pounds of force. So we can apply a load with a ram, and then we can measure deflection as it goes, as the load's being applied. So we can look at various different properties depending on the component or system we're looking at. And
Specific.
Yeah.
This is a load cell sensor. So that's actually we've placed underneath the RAM itself, so you actually can measure how much force you're applying. And these units here are deflection meters. So we would attach this, and once you're pressing or trying to deform the specific structure you're testing, this small little any measurement or any movement is recorded by.
Yeah, down to, I believe, to use an imperial term that I'm familiar with, down to like thousandths of an inch of precision in the measurement there. So
Right.
Yeah, and this over here, this is our weathering chamber. So you can see on the left side here, we have basically the exterior environment that's replicated, and then we have our interior environment on this chamber on the right, and we put a wall assembly in between and just sandwich it together, clamp it in place, and then turn it on with whatever profile that we want. We've got it partially open right now, so I can show this one side as well. Kind of inside here, so you can see we've got a box with a ton of wires coming out of it in there. And also we have these lights here as well. So we have full spectrum lighting and also UV lighting as well that we can turn on to the wall sample if needed for the testing profiles we're doing. And again, it's working with those partners that are coming to us that are looking to determine specific property of their wall assembly or their product that we're working with, and how can we run this chamber to provide the data that they're looking for to prove how it's going to perform. So, and another one on the end of training and information, we have our wall library here. So this was started with some funding from Alberta Innovates back in 2019, was enhanced a few years ago with a retrofit project with SSRIA, where we created a couple retrofit wall assemblies. Here, looking at an EIFS, or exterior insulation finish system retrofit scenario. This one here is a Larson Truss retrofit scenario. We have another one with panelized retrofit. So these are all developed to just show how these different systems and assemblies are constructed. So they're in a cutaway fashion, so you can see each layer. We've tried to vary the window detailing between each one, showing there are many different ways we can do it. Candidly, some of the window detailing measures I wouldn't personally agree with that we've done, but they will work. So with this wall assembly, we have people come in from industry. We have a lot of students come in from various programs at SAIT. When we do run the training on the new construction or retrofit side for high performance in this lab space, we can bring them over here and use these walls as examples to explain concepts to the students.
And,
Sorry, Kevin, not to cut you off.
yeah, that's all right.
No, I'll share an interesting story that happened within the last few weeks, actually, where we had a tour of people, I believe, from Korea. And when I showed them this section here, they were actually kind of puzzled. They're like, wow, that's complicated. And I've always kind of known the way we build is a little complicated, but it was interesting to hear firsthand from people from a different part of the world and how they describe, we just use concrete. Everything, our buildings are concrete. So as we've already discussed, everything depends. And I know I had to kind of highlight to them that we have a lot of wood and we have a lot of forest. So hence why we've built a lot. Our buildings evolved to be wood based, and so it was just interesting. It was just an interesting capture to some people that come for a tour from different parts of the world.
Yeah, certainly. Like my question was going to be around: have you done testing to sort of get to a point where you can definitively say this wall assembly, performs better than this one, or this versus this one, or is it just really showcasing these are all the ways people do it?
Oops. I would say it comes back to that term of it depends for the project. Like, builders really, when we look at a wall assembly for a home or a different envelope assembly, we're talking walls, foundations, roof systems. It's really how can we provide the highest amount of insulation for the lowest cost. And when we're talking inner city, at the lowest thickness as well from the wall systems, we have really tight lots that we're trying to fit these homes on. And so highest insulation, lowest thickness, lowest cost, and then also lowest risk. Which of these assemblies are the easiest to construct and make work?
That's a huge factor in this industry, especially. A lot of people.
Yeah. And
well, even sorry, just to build on the Korean perspective, right? When we compare to concrete, obviously high embedded carbon, forests are sort of considered a renewable resource, even if it's 50 years or 100 years. I know it's the way we've done it because we've had these abundant forests, but I'd be curious to see how much simpler you could, because it is a lot more straightforward when you do it with concrete. You don't have all those different layers and ingredients. And when you're trying to tie together all those things and you're opening up the complexity of doing it incorrectly, and now you got water behind the wall or something's gone wrong or some contractor messed up, where does the dust settle if we can go to something that's so much simpler to do, that maybe the numbers start to look better to go to concrete or some other style of doing it?
Yeah. And go ahead, Dave.
No, I was just going to say is we're continually working with, companies and innovators in the industry that are looking at, improving and simplifying systems. So that's all I was going to say, that it's a constant evolution. And so to your point, that we are here as an, avenue and an asset, working with industry to, try to answer those questions and to evolve the way we do actually build here.
And I think when we look at too what the best assemblies might be, how can we de-risk or make things simpler, that's where the modern methods of construction comes in as well, where we're doing we're looking at what can be manufactured in a factory instead of a site. Are we going full volumetric modular? Are we going panelized? Or are we even just looking at certain components to do in a factory that are traditionally done on site? So there's a lot of opportunities there.
Yeah, if you could get a team of people who do 1,000 of these a month versus a trades crew who's got a general handy, laborer for the day, and then just like mistakes can be made when you're doing things kind of for the first time or on a limited basis versus a crew who does it all day, every day in a factory.
Yeah.
So I just want to speak to that point. It's the pre-manufactured structure, so. Our site itself, as Ben mentioned, constantly evolving. We're just finishing up an electrical upgrade, but then we're also now going to be putting funding to look at demand side management and larger scale energy management and potentially microgrid for our site. This is determined integrated renewable technology lab. Name may change, but this is just upgraded. We also have vehicle to grid chargers that is part of a project that we need to be getting installed on our site. So we're, it's a full gamut of all applications of applied research. Green building, performance, energy conservation.
Amazing. And that's kind of like your roots right there. The Atco trailer is sort of where this entire endeavor started. I don't know if it was
Yeah.
that trailer specifically, but
It
they're all pretty similar.
It wasn't that trailer, but it's kind of interesting. Like, we look at how we adapt and move forward. This trailer was originally in 2009 was a demonstration. I think it was 2008 or 2009 at the Calgary Stampede. NMAX developed this trailer to demonstrate solar technology. So it had solar thermal, solar electric on it. There's a little shower inside. I don't know if anyone ever showered in the shower, and a battery system as well. And then after that, it sat in a field for years. They donated it to our research group. We repurposed it as kind of a student project trailer where students can go and just have a space to work in on their projects as well, where we'd go in and provide the mentoring support. Then it became a construction trailer during one round of construction here. Our wall library was housed in it. We did a full renovation. We gutted it for our wall library. And then that wall library was removed. We used it as a construction trailer as well. Again, once more, when our tent structure was replaced, and then now it's being adapted to be used for the upcoming Integrated Renewable Technology Lab.
That's
Amazing.
yes. Constant
Resiliency in action.
Yeah. Yeah.
Well, thank you for joining us on a tour. Do you have any final questions or thoughts there, Kevin?
Well, I mean, as I said, probably the first time I came through there, super impressive what you and your entire team have been able to accomplish there. So, a big shout out to SAIT and SAIT's administrators for believing in you guys and supporting you over the years, and a shout out to NMAX for their donation, and Mattamy Homes and Brookfield and the various clients that have used your facilities to push the envelope, literally and figuratively, on their buildings. And, I'm excited for the next decade of the work that comes out of that facility. You guys are really at the bleeding edge of Canadian residential and commercial building and design. And, it's like I said at the beginning, I mean, you're sort of pushing things to the limit to help us sleep more comfortably, live more comfortably, save money, save the environment. And we really appreciate the work that you're doing. So for anybody who's got a factory or a product or innovation that you're thinking about, Dean and Ben are great people to talk to, great resources to run your products through its paces. And so reach out to SAIT and the team. And, thank you so much, guys, for this extra live walkthrough.
Yeah.
Our pleasure, Kevin. Yeah, thank you.
All right.
Thanks
Not a problem.
Yeah, great. All right, guys. So it's been super insightful. To be continued. We'll try to get you back on for a follow-up down the line. And really appreciate your time today. And I hope everybody got a lot of value out of it.
Thank you.
Thanks, Kevin.
Take care.
Bye.